What's up, everybody? This is Mr. Longo, and this video is going to cover factoring, but we're going to take it a step up. These are going to be a little bit more challenging than your typical quadratic equation, yet these follow the same rules. So if you understand how to factor a trinomial or difference of two squares, these are going to be done in the same way. They're just a little bit more challenging. So if you think you're really good at factoring, I'm going to encourage you to pause the video right now and try the 5 problems we have here. There are just 5 examples for this video because it will cover everything that we need to cover in terms of factoring problems that are a little bit more challenging. So if you have a minute, pause it, give them a try. As soon as you're ready to see if you've done them correctly, click play and you'll see the step-by-step. So let's do this. So number 1, the first thing you always want to check for when you're factoring is a greatest common factor. Clearly we can factor out a 4x squared from this trinomial. That would leave us with x squared plus 7x plus 10. And now the inside is just a nice trinomial that we can figure out what multiplies to 10 but adds to 7. Do not forget your GCF. So we would have 4x squared, then we would have an x plus 5, and we would have an x plus 2. And you're done with example number 1. Moving on to example number 2. We have 2 terms, a minus sign in between, and they're perfect squares. So this is an example of factoring by the difference of 2 squares. So the first thing we would do is take the square root of each of those. So the square root of x to the 4th is x squared. Remember, you get one that's positive, one that's negative. And what is the square root of 16? It would be 4. And remember, another way to say is you're multiplying to a negative 16 but adding to 0, and you can see that's a positive 4 and a negative 4. But you're not done, because if you look closely, you have a second set of difference of 2 squares. So x squared minus 4 is also the difference of 2 squares, so that would factor to an x plus 2 and an x minus 2. Alright, so I just wanted to show you, it is a step above, but nothing has really changed. Alright, if you needed a little refresher before you continued, again, at any time that you feel that you're comfortable enough to do some of these on your own, just pause it and give them a shot. So for number 3, what multiplies to a negative 12 but adds to a negative 1, x squared? Notice that the first one is in terms of x to the 4th power. We're just going to ask ourselves that same question. The only difference is we are going to factor in terms of x squared. So this would be x squared plus 3 and x squared minus 4, because the negative 4 and the positive 3 will multiply to a negative 12 and add to a negative 1. But just like the last example, here is a difference of 2 squares. So we would factor that some more and leave it as x squared plus 3, x plus 2, and an x minus 2. Okay, so again, not that difficult, it's just a step above what we would normally do. This one, it has an x squared in the beginning, but it has a y squared at the end, and we have an xy in the middle. To factor this, we're still going to ask ourselves the same question, but a little bit different this time. So what would multiply to a 16 y squared, but add to an 8 xy? Since we're starting with an x squared, we're going to factor that in the same way. We're just going to need to add a y to the second term. So what multiplies to 16 but adds to 8? That would be 4 and 4. So this would be x plus 4y, and again, x plus 4y. And then, since they're the exact same, we can write those as the square of a binomial. That would be x plus 4y quantity squared, because we have the same thing. All right? Now, of all these questions, number 5 was probably one that you had the most trouble with if you gave it a shot first. But really, we're going to turn it into a very easy question. As we can see, we have parentheses of x minus 5. Now, if you were tempted to factor, or shall I say FOIL these and do x minus 5 squared plus 5 times x minus 5, and then of course FOIL that to get x squared minus 10x plus 25 plus 5x minus 25 plus 6, you're making a whole bunch more work for yourself. If you started by doing that and you get the same answer, I'm going to say, good job. I'm going to show you a shortcut. What if we were to just say, you know what, these guys are just annoying me. I'm just going to call that a. So a is equal to x minus 5. And I'm just going to factor a very easy quadratic instead. A squared plus 5a plus 6. What multiplies to 6 but adds to 5? That would be an a plus 2 and an a plus 3. So I'm already factored. Now the only thing I have to do is take that x minus 5 and substitute it into both of those a values. And that's just going to give me x minus 5 plus 2 and x minus 5 plus 3, leaving me with x minus 3 and x minus 2. So again, if you got that exact same answer by foiling everything out and combining like terms and then working backwards, good job. You learn that there's more than one way to do a problem. But that's just a quick, easy way to do this, so really it's up to you. All right, everybody, this is Mr. Longo, and I'm out. See you, bye.